Welcome to Psychology Corner. This is the audio version of Mastering Logic, 7 critical thinking techniques for evaluating arguments and evidence. The world is an increasingly complex environment, especially considering the vast amount of information we must sift through on a daily basis. How do we navigate everyday decision-making, social interactions, and professional contexts in a way that ensures we properly separate the significant and relevant from the noise, making objective, reason-driven choices? Intentionally applying critical thinking methods to the problems we face, whether simple or complex, seems to be the obvious answer. Careful analysis of data can protect us from misinformation, manipulation, and impulsive, damaging decision-making. It also helps us distinguish between bogus claims and credible scientific data. In this article, I will present 7 of the most significant critical thinking techniques that you can use in everyday contexts to enhance your ability to live a more objective, reason-driven life. 1. The Toulmin model of argumentation. Purpose. The Toulmin model of argumentation, developed by British philosopher Stephen Toulmin, offers a systematic way of analyzing and constructing arguments. It breaks down arguments into 6 components: claim, the main statement or conclusion; data, the evidence supporting the claim; warrant, the reasoning that connects the data to the claim; backing, additional support for the warrant; qualifier, the degree of certainty about the claim; and rebuttal, counter-arguments or conditions where the claim might not hold true. Application. This model is used in fields like law, science, politics, and ethics to clarify and evaluate the strength of arguments. It helps ensure that arguments are well structured, supported by credible evidence, and logically sound. Example. Claim: I should bring an umbrella with me today. Data: the weather forecast predicts a 70% chance of rain. Warrant: a high chance of rain suggests that bringing an umbrella is a reasonable precaution. Backing: weather forecasts are typically reliable, with meteorologists often achieving a high degree of accuracy. Qualifier: it's likely that I'll need the umbrella, although there is a possibility it might not rain. Rebuttal: if the weather turns out to be sunny, I can always leave the umbrella in my bag. 2. Reductio ad absurdum. Purpose. Reductio ad absurdum is a logical technique first used by ancient philosophers like Aristotle to demonstrate the falsity of an argument. It involves pushing an argument to its extreme or contradictory conclusion to show its falsehood. By taking an argument to an absurd or impossible outcome, it demonstrates that the original claim leads to illogical results, thus proving the claim to be incorrect. Application. This technique is widely used in philosophy, law, and debate to expose flaws in arguments by highlighting the absurdity or inconsistency of their conclusions. It helps test the validity of an idea by examining its logical consequences. Example. Claim: the Earth is flat, and all scientific evidence suggesting otherwise is fabricated. Analysis. If the Earth were flat, it would contradict centuries of scientific observations in astronomy, geology, and physics. For example, gravity would behave differently, and many space missions would be impossible. This leads to absurd outcomes, such as the need to explain why astronauts and millions of people have observed the round shape of the Earth. The contradiction proves that the Earth is not flat. 3. Bayesian probability and Bayesian updating. Purpose. Bayesian probability is a statistical method developed by Reverend Thomas Bayes in the 18th century for updating the probability of a hypothesis based on new evidence. The technique relies on Bayes' theorem, which allows for the adjustment of prior beliefs as more data becomes available. This approach helps refine predictions and decisions by continuously integrating new information. Application. Bayesian updating is widely used in fields such as data science, medicine, machine learning, and even everyday decision-making. It's especially useful when dealing with uncertain situations where the likelihood of events can change over time. Example, prior belief. I believe there's an 80% chance that a person will be on time for a meeting based on their past punctuality. New evidence. I learned that the person is currently stuck in traffic and will be delayed by at least 15 minutes. Updated belief. Using Bayesian updating, I adjust my probability of them being on time down to 30%, since the new evidence significantly lowers the likelihood of punctuality. 4. Method of doubt or Cartesian doubt. Purpose. The method of doubt, introduced by René Descartes, involves systematically doubting all beliefs that can possibly be doubted in order to arrive at fundamental truths. Descartes' goal was to identify undeniable truths by eliminating anything that could be uncertain or deceptive. Application. This technique is primarily used in philosophy and critical thinking to challenge assumptions and explore the foundations of knowledge. It encourages rigorous skepticism, forcing us to reassess the certainty of our beliefs. Example. Claim, I am sitting at my desk right now. Doubt, what if I am dreaming or in a virtual reality simulation? I can doubt the reality of my sensory experiences. Undeniable truth. However, the fact that I am thinking and doubting means I must exist in some form. Cogito ergo sum. I think, therefore I am. This is the foundational certainty I can rely on. 5. The Devil's Advocate Technique. Purpose. The Devil's Advocate technique was first formalized by the Catholic Church in the 16th century during the canonization process, where an appointed devil's advocate would argue against the sainthood of a candidate to ensure a thorough investigation. Today, the technique involves deliberately taking an opposing viewpoint in order to test the strength of an argument. By presenting counter-arguments, this method helps uncover weaknesses or overlooked aspects of a position, promoting deeper analysis and understanding. Application. This technique is particularly useful in group discussions, decision-making, and problem-solving. It helps ensure that all perspectives are considered and that potential flaws in reasoning are identified before making decisions. Example. Claim. I should buy a new smartphone because my current one is outdated and slow. Devil's advocate argument. But is it really necessary to buy a new phone? Your current phone still works for basic functions, and buying a new one might be an unnecessary expense. Additionally, the environmental impact of constantly upgrading electronics contributes to e-waste. Revised argument. After considering the counterpoints, you might decide that upgrading the phone could be worth it if the new device will significantly improve your productivity or address specific needs, but it's important to balance the cost and environmental impact. 6. Occam's razor. Purpose. Occam's razor is a principle attributed to the 14th century English philosopher William of Occam. It suggests that when faced with competing hypotheses or explanations, the one with the fewest assumptions should be preferred. In other words, the simplest explanation is often the best. This principle has been used for centuries as a tool to eliminate unnecessary complexity and focus on the most straightforward solutions. Application. Occam's razor is commonly used in science, medicine, and problem-solving to streamline solutions and avoid overcomplicating matters. It can help clarify reasoning by removing extraneous variables or assumptions. Example. Claim. My car won't start because the engine is broken and the battery is also dead. Simpler hypothesis. The car won't start simply because the battery is dead. Occam's razor, since a dead battery is a more straightforward explanation. We replace the battery first and the car will likely start without further complications. 7. The Sorites paradox or the paradox of the heap. Purpose. The Sorites paradox, also known as the paradox of the heap, was first described by the ancient Greek philosopher Eubulides of Miletus. It arises from situations where small changes seem insignificant, but when accumulated, they lead to a significant effect. The paradox challenges the idea of when a change or transformation becomes noticeable, questioning where the boundary between different states lies. This problem has been explored in philosophy to examine concepts like vagueness and the nature of gradual change. Application. This paradox is used in philosophy and logic to explore concepts like vagueness, boundaries, and the nature of gradual change. It helps in understanding concepts that do not have clear-cut definitions but rather exist along a spectrum. Example. Claim. A pile of sand is still a heap if it contains a large amount of sand. Gradual change. If you remove a single grain of sand, is it still a heap? What if you remove 100 grains? At what point does the pile stop being a heap? Analysis. The Sorites paradox illustrates how it is difficult to draw a precise line between a heap and a non-heap, highlighting the challenges of defining vague terms. By applying these 7 critical thinking techniques, you can enhance your ability to evaluate arguments and evidence with greater clarity and precision. Whether using the Toulmin model to structure your reasoning, Occam's razor to simplify complex issues, or the devil's advocate technique to uncover hidden weaknesses, each method offers a valuable approach for making more informed decisions. Mastering these tools allows you to think more critically, separate fact from fiction, and approach problems with a more objective mindset in all areas of life.